Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
The Refactoring Circus, and as with all circuses, the best thing is the elephants, and the elephant today is refactoring. And if you all remember the parable, then we need a lot of experts to describe the elephant from their own standpoint. So I've got three experts here who are going to describe what they think of as refactoring. And I'm not going to even introduce them because that's going to use up time, and you should all have your Windows phone and be using the conference app on it, which has all the full bios, so you can look up how wonderful they are on your own. But we're going to start off with a really quick introduction by Emerson just to give an overview of refactoring to make sure that everybody has the right context, and then we'll dive into the individual presentations. Thank you.
All right, so just a really fast introduction to refactoring. So who here uses refactoring tools? Most of us, cool, great. And who knows what refactoring is? Pretty much everybody. Okay, so I think this will be a little bit of a review, but it'll be good for us. All right, so suppose that I've got a little bit of code. We have this gorilla class, and it's just got this pause method. Suppose I make a change to it. I want to introduce this variable. We'll call it paw count of 4, and we'll just return it. So you notice the code here does the same thing it did before, just the structure has changed a little bit. We'll make another change. We'll make this gorilla class implement a primate interface, okay, and we'll put the pause method in that primate interface. So again, code still does the same thing, but the structure is just a bit different. And we'll make one more change. We'll say we don't like the word pause, and we like feet better. I still don't think that's quite right, but we like feet better. So we'll change it in the declaration of feet in gorilla and also in primate. And so each of these changes we call a refactoring, and each of these refactorings has a name. So this particular refactoring at the top we call introduce explaining variable, or sometimes we call it extract local variable. The next one we call extract interface. And this last one is rename method. And so Martin Fowler's book kind of popularized this notion of refactoring, although it certainly existed before then. And certainly we had refactoring for a long time, right? Ever since programs have been structured, they've needed to be restructured. But these are kind of the words we use when we're talking about refactoring, when we're talking about these changes. And there were 72 in Martin Fowler's book, but there's certainly been many since, and it probably wasn't even complete at the time. So those changes, now typically we're going to make those by hand, right? We're going to type the things that we want to change. But we can also use tools. So for instance, let's look at this last change we made. If we wanted to use a tool and say, a lot of the work I do is in Eclipse, what I would typically do is select the thing I want to rename, go to my menu. Typically there's a refactoring menu. There's a whole bunch of refactorings on it. And there's a rename one at the top. I'm going to choose that. Going to get some options to change to do the refactoring, especially the new name. I press OK, and it does the change for me. Okay, so it does what I would have done by hand anyway. So why would I even want to use a tool for this? Well, it's because refactoring tools promise two things. The first thing that it promises is that it can make the change faster than you can make by hand. So these particular changes were quite small and quite local because they make good examples. But a lot of refactorings change a lot of code around. And if that's the case, you don't want to have to find all the references yourself. The tool knows the semantics of the program. There's a lot of complex machinery behind these tools, and we'll hear about that in a minute. And so the tool can do all the analysis for you. It can update all the references that it needs to. And so it's quite fast. And at the same time, the tools are less likely to introduce bugs than you are by hand. That's kind of the promise. The tools know the semantics of the program. They're not going to forget a reference like you might. So those are the two promises of refactoring tools, and I think that's all you need to know about refactoring. So Karen is up next.
Okay, can you guys hear me? So my name is Karen Ying, and I'm the lead program manager. I actually work on the product side in Visual Studio. My team owns the programming languages C# and VB, so we do all the language design for C#, the language C# and VB. We've done LINQ, asynchronous programming, and dynamic. We also own the tooling side, so things like refactoring tools and IntelliSense, formatting. I'm going to talk to you a little bit about a project we have called Roslyn. And the way that it kind of relates into the refactoring tools that Emerson kind of introduced is one of the challenges we've had in Visual Studio is being able to provide enough of the compiler's code analysis so that anyone can come up to Visual Studio to C# or VB and build your own refactoring tools. So I'm going to take a little bit of a step back and give you an overview of what we're trying to do in the Roslyn project and what kind of information we're surfacing as part of the compilers in order to build and allow people to write refactorings. So in general, Roslyn came from this concept that our compilers today were just these big black boxes that people needed to use. It takes source code in, and it generates some amount of IL. And if you wanted to be in the refactoring space, you had to write a lot of infrastructure, such as a parser, a binder, expose some syntax trees, semantic analysis. You had to build all of that yourself to understand C# and VB code. What we want to do is really open up the compiler so it's no longer a black box. We want to put a public API on top in order to, allow in all of these different scenarios. The first one kind of being this language object model that represents your code, which really enables this world of refactorings. As Emerson was mentioning, if you're doing a rename, you might want to rename foo, but you need to find all the references to foo and then update your source code to then do the rename to all of those. That language object model will represent everything you need in order to say, call find all references, update my source code. We're also looking at things that doing something like a read eval print loop. So allowing this compiler to really be used as a little hostable compiler where you can evaluate just small snippets of expressions to build something that we're calling the interactive window. Other scenarios such as DSL embedding or hosting in other contexts, but just really opening up the compiler to enable all of these different scenarios. So what kinds of things does it entail? So codename Roslyn, you might have heard the term compiler as a service before. We kind of started leaning away from calling it compiler as a service because it leads to some confusion with, is it a service that belongs in the cloud? Is it a cloud service that you get from Azure? And it's not. So what codename Roslyn is it's a project that will deliver the new C# and VB compilers and IDEs. The compilers before, back in the day, today, they're actually written in C++. We are actually rebuilding the compilers so that we can really componentize each piece of it and building it in managed code. So the C# compiler in C#, the VB compiler in VB. Roslyn contains a few things, so it will include the managed compilers and the language services. So language services being essentially the underlying service that provides IntelliSense or refactoring or all the tools that understand language richness. The code analysis APIs, language service extensibility, which I'll show you a few demos of later, and a read eval print loop. So if I talk about what Roslyn's going to expose, this is really, this is not necessarily related to refactoring, but all the things that you might need to build that refactoring. So it's really about breaking the compiler into components. So as we rebuild the compiler, we're rebuilding the parser, the piece that takes the source code, tokenizes it, forms a syntax tree. We're rebuilding the symbol table and the metadata import. The binder is a large chunk of what the compiler does, and this is where all the rich analysis happens, where symbol table might have the name of the thing. The binder takes the expressions from the parser and connects it to the names in the symbol table. And then a small piece is the IL emitter. And on top of that, we're exposing these types of APIs. So from the parser, we're going to expose the syntax tree API. From the symbol, we'll do a symbol API. From the binder, we're exposing a binding and flow analysis APIs. So for instance, if you wanted to build the extract method refactoring, being able to detect how code flows in and out of methods. And then also exposing a small piece, which is the emit API, so you can generate IL from that. On top of that, key piece for us is building the language service. Because we are trying to build a public API that will last for the next few decades, I guess, for C# and VB. What we're doing is we're actually building all of our IDE team builds all of our language service features on top of the public Roslyn APIs. So as soon as we build a syntax tree, our team is building things like formatter, the outliner, the colorizer. As soon as we get symbol API, you start seeing these kind of tools like the object browser or a way to visualize different types of things. When you get the binding and flow analysis APIs, that becomes the heart of really what we do. And so you start seeing the refactorings come online, completion lists come online, and then even things like edit and continue as you start dealing with IL and diffs. I'll pull back a little here and talk a little bit about our syntax trees. The reason I'm going to talk about syntax trees is it's the fundamental data structure that we expose in Roslyn. So you've seen some other models potentially that might expose a semantic tree. The syntax tree is the one way to navigate through Roslyn APIs, and you can ask questions to get answer semantic questions. But some principles we have in our syntax trees that will be important as you build refactorings and other code analysis tools on top is it's an immutable syntax tree, which means you never have to hold a lock. It never changes under you. It can work on multiple threads. It's also, this tree itself is complete and consistent. So in our trees, we actually build everything inside of it. It's completely round-trippable from source text to syntax tree back to source text. Every node itself knows what its relative span is. It also knows how to call back to its parent. We also build things that we coin trivia, which really means the white space, comments, all of that other stuff is actually in the tree as well. Our trees are resilient, so the errors are actually treated as data. So a lot of times when you're building refactorings or other tools, it's actually detecting where the error is that becomes really important. So our trees are resilient to errors. Errors are built inside, and so again, an error tree, a piece of source code that has errors in it is also round-trippable to a syntax tree, and that is again round-trippable back to that source code with those errors inside. And they're highly efficient. So I mentioned that this is an immutable data structure, which means that you're not mutating the syntax tree itself. If you wanted to make a modification to it, for instance, add a parameter, we're actually building up another snapshot of a tree, and we're very efficient in how we reuse under the covers different nodes to build that up quickly. So I'll show you how we represent these nodes. So you can see that piece of source code. It just has a class. It has a main method. We reveal the syntax trees contain strongly typed nodes that you can walk down. So this piece of code is represented by a compilation unit. You then walk down, and the class is represented by a type declaration. Then you have your member declaration, your parameter list. We also represent the tokens. So you can see here, even that token end of file is represented off of compilation unit. You can see where class C and the void end method is represented, including the open and close brace and parentheses. We represent trivia at this point as well. And so you can see that every token in our model is able to hold leading or trailing trivia. So those orange pieces here, it really holds everything down to that comment. If you look all the way on the other side, you can see that that comment there is a trailing trivia off of the close brace. It's kind of an easier view to look at. So let's take a look at what happens if you wanted to add a parameter. So this might be the first step in one refactoring you're trying to do. So let's say I want to add a parameter to my end method. What would happen is, I would then, to the parameter list, I would then add a parameter, which also contains predefined type int. Because it is, again, an immutable model, the entire spine of this changes. But all the other nodes, or if you look at that block over there, we actually can reuse under the covers. We're reusing the nodes that haven't changed, but the spine changed as you added a parameter. So a last piece that's kind of important here is I mentioned that we expose the binding and the flow analysis APIs and all of the semantic knowledge. So the way that you get to that, the syntax tree is really your navigation mechanism as you walk down nodes, and it's closely mapped to source. If you wanted to ask semantic questions about it, you create a compilation. So you add the syntax trees plus the references, and then you get access to essentially a compilation object that allows you to then ask questions along the symbols API, binding API, flow analysis, diagnostics, and emit. The last piece I'll see is just kind of closing thoughts, and this is really to seed your thinking on what kind of research you can do. One of the big reasons we're doing Roslyn and that we're showing it at the faculty summit and in the academic community early is because we want to open the compilers to allow language research, to allow tool research, code analysis, kind of just rich things that we really can build once we have this kind of infrastructure. So, do we want to do... Emerson.
So do you have plans how do you plan on keeping up with new language features in .NET?
Well, one advantage that we have is we are the team that owns the language We are the team that owns the language design, and we are the team that owns the IDE tooling. So whenever you see the Roslyn APIs come out, it will be shipped the exact same time the language features the IDE does. Anders Heilsberg, the designer of C#, is actually the lead architect of Roslyn as well. So you'll see everything stay in sync. And we do think about versioning to enable a world where we can innovate in the language, allow it to surface through the API, and then also provide agile tooling for it, be agile in providing tooling for it.
Is this available yet, or if not, when?
It is not available yet. It will be available to some degree soon. And I can't reveal what that date is yet.
Hi, how are you guiding the testing process to make sure that this compiler is essentially creating the same IL or compatible with the previous one?
Again, one of the advantages we have is that we actually are that language team, so we actually have the entire legacy testbed. So in terms of parity, one of our goals, goals is what code that used to build needs to build. We also verify, we have an IL verification process to make sure that we're producing the same thing. It will be challenging to get everything perfectly, but it really is a goal that we're striving for.
This is really a question about the compiler, but what kind of flow analysis is available through this interface?
Gosh, a lot of it. So I think you should be able to ask any type of thing that you would want there, how variables flow in and out, ref variables as well. But the way that we've designed it is we've actually built our entire extract method refactoring on top of it, so you should be able to ask all the questions that you need. One of the reasons we're going to give the API out early before you actually see it in the product is we want people to be asking questions using the flow analysis API, making sure that you can ask all the questions you'd want to ask.
Just from a language research point of view, is it possible to modify the parser so that it accepts a slightly extended C# type language and then generates a syntax tree which would then work through your backend?
So you can't modify the parser. So the way that, as long as you stay in C# constructs, you can definitely take the syntax tree, find something, generate out full properties, and then put it back in the pipeline. You can't create your own language features. One thing we are heavily considering with this project, though, is eventually allowing an open source version of the compiler for research that would allow you to pursue and look at different language features if you want. Today, you can't. So the version of Roslyn that you'd get, you can't modify the parser to accept a non-C# sanctioned construct.
Could you create your own parser and generate your syntax tree?
You could. You could definitely do that. We will definitely surface a bunch of public items, and you can follow the same model for it. Yeah.
Okay, last question, and then we'll move on to the next speaker.
Now, this is a follow-up question to the one that Wayne just asked, but if we wanted to have annotations in the program that are not semantically meaningful, could we, for instance, recognize particular types of comment?
You could. So that you can definitely do. So if it's a different kind of comment or some kind of indicator, you can definitely pull it from the syntax tree, recognize that piece, do a code gen of something else you want to add to the tree, and then plug it back in the pipeline.
Okay, great. Thanks again to Karen. And now we'll have Ralph come up and talk.
So I was planning to help motivate you with things you could do with Roslyn, talk about how we can go beyond standard refactoring. In fact, I thought of calling this Beyond Refactoring. There's already a paper with that topic, or that title. So I'm not sure if people know me very well. So as a way of introduction, is talk about some of the work I've done with refactoring. Bill Updike was the first PhD student who did refactoring work with me. I actually got interested in refactoring by looking at how people developed object-oriented frameworks, because I always saw that there was always a lot of rewriting, and I was talking with people at Tektronix, Tech Labs, seeing how they were doing things. And I said, this is a key part of how you design frameworks. So his thesis was, he was from Bell Labs, and so he was interested in C++, and he built some prototypes, but one of the things that was really obvious to us when we jumped into it was that building some reliable C++ tools was beyond us. I calculated something like 20 man-years it would probably take us to do it. So I was interested in making some tools and talked to some other students. There's Don Roberts, John Brandt and Don Roberts built a tool for Smalltalk, the Smalltalk refactoring browser, which was the first refactoring tool that got wide use, because it was pretty widely used in the Smalltalk community, which admittedly was a very small community, but still about half of them were using it at one point. It still gets used. It's still out there. Alejandra Garrido was looking at C. And in particular, when we're looking at refactoring C programs, the pointer analysis is a hard topic, but then lots of people are doing research on it. The other thing that was clearly a pain in the neck was the C preprocessor. So that's what she focused on. She came up with a way of dealing with the C preprocessor, how you could do refactoring and not let the C preprocessor mess you up. Danny Digg was looking more at an application of refactoring, being able to use refactoring to handle component evolution, because if you're reusing some library, they come out with a new version of the library which isn't quite backward compatible. He actually did some analysis of libraries, of Java libraries, and what was it that made them not backward compatible. And it was basically like 85% of those changes were essentially refactorings that didn't get service. Not every change can be that way, but a pretty wide percentage. And so then looking at tool support to automate upgrading your application when a new version of the library came out. Munawar, I'm going to talk more about his work looking at security and the changes that people make to their code to make them be more secure, and thinking of those as refactorings, same type of program transformations. And Jeff Overby is going to defend his thesis in 2 weeks. This is another tool. Fortran is a IDE for Fortran that does refactoring. They were concerned in particular, not just about traditional refactoring, but also the tuning you do for porting your Fortran program to a new supercomputer. So again, it's sort of incremental program changes. But his PhD thesis is really much more on the infrastructure that you need. So it'll be interesting to compare that with what they're doing in Roslyn, because it's sort of comparable in many ways. So I've been working on refactoring for a long time. One of the reasons why I'm interested in refactoring is because it's really about how people change programs. I think we often overemphasize, you might say, maybe the static nature of a program or starting programs from scratch. What programmers really do is they take code and keep adding features to it, keep changing it. And so thinking about programs as a living thing is important. And refactoring takes this idea that you are making small steps, always trying to keep your program running. So you don't want to just rip it apart and then months later finally get it working again. That's not what you should be doing. Programmers know you should just keep making small changes. So it's really about evolution, not revolution. And it fits into that. Now, another thing I like about refactoring is there's an emphasis on testing, sort of integration with testing. If you are refactoring without a tool, especially, you'd better have a good test suite and make a few changes and run your test suite. And that's sort of part of what you learn when you're doing refactoring. With a good tool, maybe you can go a little bit further without tests. But one of the issues people always have is how good are your refactoring tools? Do they really manage to keep from introducing any bugs? And the sad fact is that all the tools you look at out there all have something. They all have bugs. They're not 100% reliable. But this doesn't matter as much in practice, because people who are refactoring usually have test suites, and they don't depend only on the tools. They depend partly on their test suite. So I like that aspect of refactoring. And even though people who are interested in refactoring all are into automation, we're all building tools and we're trying to automate things, we're not trying to take away from the programmer. We're trying to empower the programmer. The programmer is still in charge. We're trying to give power tools to help the programmer. And so those are all things I like about refactoring. And when we've gone off in different areas, and often we'll say we're refactoring for this or refactoring for that. You say, is this really refactoring? Is this really what they're doing? Well, maybe not, but we're trying to do stuff incrementally. We're trying to leave power with the programmer, provide power tools. We're doing the similar type of analysis. Integration with testing, all these other things are the same. And so it feels to us like refactoring, even though technically it may not be refactoring. So my point is, refactoring, if thought of from this point of view, is actually a pretty big topic. And tools like Roslyn will enable all those things. And so we can go off and do things that are not, strictly speaking, refactoring, but are empowered by these tools. Okay, so there's been a big deal about behavior preservation. And I think I may have actually started that. Of arguing, saying that because this is sort of how refactorings are different from just bug fixing, is that you can run your old test suite. You aren't supposed to be changing anything. Now, when you look in detail at what people are doing, and you, again, look at the tools as well that we're using, they're actually not as good at behavior preservation as we sort of let on when we were first describing it. But the idea is that you're changing the structure of the program, not changing the behavior. Martin Fowler, in his definition of refactoring, says something like, a refactoring is where you're improving the structure of the program without changing the behavior. And I actually don't like that, because how do you know if you're improving it or not? And sometimes one person thinks you're improving it and somebody else thinks you are making it worse. But we certainly are changing the structure of a program without trying to change the behavior. And that means your old tests are going to keep on working. You're not supposed to be putting new bugs in the program, not necessarily getting rid of the old ones, but not putting in new ones. But the reality is that there isn't a tool out there that can guarantee behavior preservation. In some cases, you can sort of prove you can't, that they're doing the kind of changes that you can't possibly. And in other cases, well, we probably could do a perfect job, but they're written by humans as well, so they've got bugs in them as well. And in fact, programmers often want to change behavior, and that's why we're changing the programs, is because we want to change. So here's an example of rename. A rename is like the most boring, the most obvious refactoring there is, and yet, if you have a language, so that's one nice thing about C. You really rename in C really can be absolutely behavior preservation. But in a language with reflection, whether it's C# or Java, and we did it first in Smalltalk, which is quite reflective, how do you know that there isn't some program somewhere reading something in from a file and using some reflection to go call a method? You change the name of a method, how do you know? Well, you don't know. Now, programmers usually know whether you're doing that or not. And so they, that's not going to be a problem. And so they're very confident that this will be a safe change. But if you don't know the code, if you're going in and trying to refactor somebody else's code, there might be something going on that you don't know about. And so you could have a tool that warns you, can go off and analyze and say, well, there's no reflection here, so that's safe, or there is reflection, so that's dangerous. What is more likely to happen is that your tool will know about certain libraries and certain ways that reflection is used. So like in Smalltalk, it was often used for menus. Nowadays with Java and C#, there's a dependency injection type things where you have XML files that tell how your components are together, and you'll have class names in there. When you do a rename of your class, you ought to go off and find those names in the XML files and update them. And they're used in stereotypical ways. As long as that's the way reflection is being used, the tool can handle it pretty well. So in practice, it's not that big a deal. Now in theory, it's a problem because you can't guarantee 100% that your tool, but in practice, programmers are happy with it. There's a lot of changes, so we've done a lot of work in parallelism, trying to introduce parallelism, and there it's more a matter that the analysis you have to do to guarantee is even harder, and so typically you can either be really conservative or you can just say, well, there's going to be some places, that's what undo is for. You have your tests and rely on that. I'll talk some about security, because Munawar worked on that. And there's a lot of similar areas of trying to make your system partition it to make it be more reliable, so part can crash and the other part can keep on going. If you're changing libraries, so changing from one database to another, changing the user interface, so lots of changes like that people want to make, and it's not clear. They clearly are trying to change some aspect of the behavior, but there's some other way in which you can say, I want my program to keep doing the same thing it did before, just with a different database, or just with a different user interface. Okay. So after Danny Digg did his PhD with me, he was off looking at applying refactoring to introducing parallelism. And he was doing this in a context of Java with there's these new Java APIs that are concurrent collections of various sorts. And so it was really a kind of library introduction, of replacing one library with another. And he has a bunch of different tools, concurrencer, relooper, immutator. He always comes up with nice names of things. So some of these are to introduce parallelism. So in concurrencer, it would look for divide and conquer type algorithms and could replace this with fork join, use of the fork join. In relooper, it would look for iterating over arrays, and you could replace the arrays with these parallel arrays, and then you could do the iteration in parallel, and it would do the the variety of different parallel algorithms so that's introducing parallelism. Other aspect is that you have to make the parallelism safer, get rid of the need to have locks, or to make them be more efficient. And so I'll talk about immutable objects as one of those techniques. So you could say, well, is this really refactoring? Well, I don't know if it's really refactoring, because that sort of depends on how you define it. But it is very similar to refactoring in the ways I said, in that we put it in the IDE. You see something that you don't like and you want to try changing it. You automate that change. It's very incremental. It does analysis to tell you whether or not that's safe. Actually, we often will say, we know it's safe, we know it's not safe, or we're not sure. Do you want to do it anyway? And of course, it remembers the changes so you can undo them if you don't like them. And in general, these changes we're trying to make changes the way programmers do. We're trying to help programmers do what they normally do faster and better, rather than coming up with a whole new way of doing it. And of course, sometimes we do want to come up with a new way of doing things, but that's not been Danny's approach. He studies how programmers make changes, looks to see those changes, and tries to provide automation for them. And so one of those, the immutator, which makes immutable objects. This is a sort of a classic thing, not just in parallel programming. People can use it for lots of purposes, where you've got a class with state that changes, and then you decide that you would like to make it be immutable. So it might be something like a money object, and you don't really want to go changing the currency of the money object on the fly. When you add two monies together, it'll give you a new money object rather than modifying the existing one. So you often have to change it. If you had written the program before where you were auto-incrementing a money object, then you have to change your program so that instead of that, you will add one money object to another and have it create a new one. So you want to change your class so that you only assign instance variables in the constructor, and that any of those methods that are modifying the instance variables are instead going to produce a new object. And there might be some cases where you really did need to have an object that was changing its state, has side effects. And so then you have to put another level around it. Anyway, there's a series of changes that can make, it's not in fact a single transformation, it's sort of a series of transformations that you make on your program. And again, this is something that's quite useful in parallel programming, but in fact this program transformation is not just about parallel programming. You could use it in distributed systems or with databases and various other places. So Munawar was very interested in security, and when he came to Illinois, he wanted to work on on patterns of security. So he came to talk to me about that, and I've done a lot of work with programming patterns, but I didn't know anything about security at the time. And working with him over the years, I've learned a lot. But one of the things that struck me was that a lot of these patterns were, in fact, ways of fixing different problems, and they were program transformations. And maybe we should think about them like refactoring. And so he ended up with a catalog of these program transformations. And there's just a variety. They cover a wide range. There's no opinion. We don't believe like this is a complete catalog. It's all the ones you'd ever want. It just is a bunch of stuff that we have seen. And when he goes off and you look at bug reports for security problems, you see these things come up over and over again. And then these were, and some of them you're not quite sure how you automate, but most of these are things you can automate. So this another library replacement where you have some sort of a string library. And if you aren't careful, you can have buffer overruns. Well, you can replace it with a string library that is guaranteed not to have those problems. But of course, you have to convert use of one library to use of another one. With got some SQL injection attack, some other type of injection attack. You have to trace the flow of data from the user down to the database or wherever the injection attack is taking place. And did you actually, you have to make sure everything gets cleaned, all the data gets checked as it goes from one to the other. There's partitioning, where you have a program, a big program, and you want to split it into smaller pieces, each in its own security domain, where maybe one part has to be run as root, another part's reading and writing files. You really don't want the program reading and writing files to be root. So if you can make the part that has to be root off in the corner with very few operations it's going to be doing, then the whole thing is safer, because if you break into one part, you won't affect the other. Lots of different changes. The thing about these security transformations is that you really do want to change behavior. That's the whole point of them. Right? You're trying to prevent somebody from breaking into the system. So they used to be able to break in, and now they're not going to be able to break in. So you definitely want to change behavior. But in some sense, this is unwanted behavior. You want to eliminate unwanted behavior. You want to preserve the wanted behavior. So you have to distinguish between the good behavior and the bad behavior. We only want to change the bad behavior, not the good behavior. It makes it a little difficult to, is this behavior preserving or not? Well, it's preserving some behavior, but other behavior we don't want to preserve. So you end up with so the library replacement is the old string copy, and there's a bunch of these different libraries that do it better. This is the GNU one. And it takes a count, so you have to pass, and it also changes types of things. So you don't just have a string being a pointer to chars, but instead it is a data structure that has the count in it. And so the problem in doing this is you have to figure out what the counts are, and sometimes they're pretty easy to tell, and sometimes they're not so easy to tell when you're doing a code analysis. There are times, and he would apply this to a lot of programs, go through, do transformations on it, and there would be times when it couldn't tell, but he'd get 95% or something like that of the cases. And again, we think of this as an interactive form where the ones that it couldn't handle, then a human would have to look at and figure out what to do. I guess I already talked about the partitioning. Partitioning turns out to actually be a pretty important thing in security, and where they really want, when we think of modularity, but with security, it's more than just separate modules. You want separate address spaces. You want it that when someone breaks into one, there's no physical way they could get access to the other. So typically you're trying to have separate processes that are communicating through some inter-process communication mechanism, and things that used to be pointers, now you want to be, you want some other type of ID to refer to. So this library replacement in general is a pretty typical type of change. There's a lot of things where we basically want to replace one library, one API with another one, which is more or less the same. You can make mapping rules between them, but they aren't exactly the same. And optimizations in general are often that way. You want to give a special purpose faster library. And when you're dealing with reliability, you're replacing an unreliable library that it's usually that there's going to be more error messages that detect failure, and you have to be able to respond to the failure when they detect them. And sometimes it's just that there is a old library that no one's supporting anymore, and you want to replace it with something that now has become a standard. Don Roberts and John Brandt, who did the first refactoring tool, a couple years ago, they did a project where they converted a big system that was done in Borland, Delphi, I think it was, to C# and .NET. And actually the languages themselves aren't that different, but the libraries are pretty different. And so being able to replace that, and it's like 1.5 million lines of code, so lots of different library changes. So there's really both of these are big issues, and partitioning I think is a pretty big issue. Lots of reasons that we change them. We think of just the reuse, but the security and maintainability and fault tolerance are all different reasons for partitioning. Okay, so I had one extra thing I was going to talk about, but I'm going to skip that because I'm running out of time. This is just about enhancing, adding a new feature. So hopefully the slides will be, I'm going to skip through there. I had pretty pictures, but I won't talk about them. Okay. So we've made a big deal about behavior preservation because, in fact, programmers do want to have confidence in the tools. But often the kind of changes we want to make are not about preserving behavior. I think what's more important is being able to say what we want to change, what we don't want to change, having an idea of that. And I think what's important is, one of the things that's important from refactoring is if we focus on a particular kind of change we want to make, we can understand it, we can make tools for it. Refactoring, the traditional refactoring, is probably only 2% or 3% of the kind of changes we make. It's a pretty small percentage, but because we can understand it and make that much easier, it makes the overall programmer's life easier. It's important to keep the programmer in control. And we shouldn't think about change as a big batch thing. Change is something that happens every day. We should make it real easy to use it and make small steps. So I hope you see that what the Roslyn people were doing fits into that. I think there's lots and lots of opportunities to build tools for all kinds of things on top of that. So a challenge for everybody is a lot of people will say, they'll say something like, if you really want to do such and so, this important thing that I study, you can't just leave it to the tail end of the project. You've got to focus on it from the very beginning. You can't add in whatever. And that was obviously the security people there. I said you can't add in security. You've got to design it in from the beginning. But performance people will say the same thing too. Well, you can't just take some old code and port. And there's truth to that. I think to actually get the very best, probably you do want to. But the fact is that you start a project, you don't know what's going to be important, and it's always going to be the case that you can't make everything can't be important. You can't think about everything at the beginning. And so it's always going to be the case that halfway in the middle of the project, you're going to realize, oh no, we ought to be thinking about security. Or oh no, we're going to have to be thinking about this. I mean, it's just inevitable. It's always going to happen. And so we need, for every single topic where people say, you have to do this in the beginning, no, we really need to figure out how we can add it in, because that's going to happen. And I think in general, well, yeah, it probably is more expensive to do it later than to do it right from the beginning. But we are going to have to, so we need to figure out how to do it anyway. And I think this sort of refactoring approach, tools like Roslyn are a basis for that. Thank you. Any questions?
As somebody who works on behavior preservation, I very much appreciate you sort of articulating some of the examples where it almost happens. And it strikes me that there seems to be sort of two things going on. One is context. I preserve behavior almost because if you reflect on names, it's broken, right? And the other is abstraction. Buffer overflow attacks could be observed, but they're abstraction violating attacks. That's the category, right? So I'm preserving, your example preserves behavior modulo that idealization.
Yep.
It seems to be a way to think about making the word almost more precise.
Yes, I agree. That's good.
Thank you. You gave a number of examples. Is there any? Are you aware of any work with real-time software? I mean, if you look at timing issues, then almost no transformation is behavior preserving. And the sorts of transformation you often want to make seem almost opposite to what you want to do in terms of, are you aware of any work there?
So we do a lot of work with optimization in general, more for the high-performance computing or just parallelism rather than pure real-time. But there, the whole point of the change is to make your program faster. So you, in some sense, are concerned about changing the behavior. And if you have a transformation that actually makes the program slower, that's very bad. That's sort of opposite of what you're trying to do. So you're right that the kind of changes you do when you're optimizing tend to make your programs harder to understand, harder to read. They tend to be the exact opposite of the changes that you're making when you're trying to make your software be more reusable or just easier to understand. But they aren't, in theory, different, because something like inlining or pulling a method out, you could do that in either context. A lot of the little changes are going to be the same. Certainly something like loop unrolling is not something that you're improving the appearance of your code at all. It's entirely for, so there are some optimizations that are entirely for performance reasons. But I mean, part of the problem with that is that we don't necessarily have a really good semantics for the timing, and so being able to reason about that carefully is difficult. But people do this. I mean, I look at how people work with real-time systems where they're carefully timing things and they're tweaking it and making little changes. To me, it's very similar. It fits into the same pattern. It's a somewhat different set of transformations, but it's very, very similar.
Thank you.
Thank you.
All right, so good to see you again. So we've heard some really interesting talks about refactoring so far. A lot of my work is in sort of the empirical side of refactoring, thinking about how people are, thinking about how people are using refactoring tools and using the information about how people are using refactoring tools to make those tools better. So, as I mentioned, refactoring tools are really great. Like, I think they're one of my favorite tools to use because they're faster, and again, in a certain sense, they kind of guarantee safety. But I think we can all agree that at least they're safer than I would be without the tools. But there's a lot of dependencies there that we need to sort of be concerned about. So if refactoring tools really are going to help us, if they're something that we should be using all the time, then the refactoring tools need to support the types of refactorings that we do. So what you'll see with most refactoring tools is that they only support a subset of the types of all the different kinds of refactorings that are out there. So like I said, Martin Fowler's book had 72 different refactorings when you look at Eclipse or Visual Studio. Not all of those are implemented. So are the typical refactorings that are implemented, are those the same ones that people actually do? Is the way that people refactor really the way that tools support that activity? So sometimes there's a mismatch between what you want to do and the way that the tools do it. So we can look at that question as well. And finally, do programmers use all the features of refactoring tools? So refactoring kind of has this core idea of changing certain things, but there's always these configuration options that we can change, and do people really use those or not? So these are sort of three of the questions that my research has tried to answer, and I want to lead you through each of these and talk about some of the answers that we've come up with, and then maybe some solutions for these, which are, if the answer is no to any one of these questions, what can we do to make the tools fit a little better? So if tools don't fit with the way people refactor, how can we modify those tools to help? So I want to talk about a study of refactoring that we did. But to do so, I want to introduce a little bit of notation. So so here we have a bunch of changes. We change a class foo to bar. We add an instance variable and a constructor, and then we say we don't want to use a constructor anymore. We want to use a factory method. Okay. So let's think of each of these changes as different types of changes. On one hand, we have the refactorings. On the other hand, we have the non-refactorings, the behavior changing changes. Okay, and we'll use different colors. We'll use pink because I like pink. Pink will be the refactorings, and blue will be the non-refactorings. Okay, and as we've talked about, these you can do with tools. Some of the changes you can do with tools, some of them you don't. And it's really important to realize that you always have the option of using the tools or not. And sometimes it's conscious, sometimes it's not. But let's say I did this last refactoring here with a tool. So here's the introduce factory tool in Eclipse. And I'm going to use a little tool icon for doing it with a tool. Okay, so I'm not actually going to talk about code much at all here. But what I just kind of want to abstract over this and talk about refactoring changes and non-refactoring changes. So we'll use blue boxes as non-refactoring and pink boxes as refactoring. And then the little tool icon will mean I did it with a tool. Okay, and then we can think of the changes to a program as these sequences of refactorings and non-refactorings. Some of the refactorings people do with tools, some of them they don't. Okay, so we did a study where we took a couple of different data sets and we kind of correlated them together. So the two primary data sets we used were the code in a version control system. Okay, what we can do with that is we can look at each successive version of the program, and we can compare the successive versions together and kind of infer where people were doing refactoring. Oh, they used to have a class named bar and now it's called foo. Looks like they did a refactoring there. And what we also have is, for this particular study, we also have which refactoring tools they used at which time. Okay, they gave us basically the refactoring histories. Eclipse happens to keep this. And so we use that information, and we can kind of correlate the two together. We can kind of see which changes they made in the code and which refactoring tools they used. And that information gives us some data about when tools are used and how they're used and in what way. So we did a study. This is with my colleagues Chris Parnan at Georgia Tech and Andrew Black at Portland State University. And we did a couple of case studies with two small development teams, around 4 core developers in each team. And we had about 3 years of history, both in the version control system and their refactoring tool. These are both Eclipse teams, not Eclipse users. They used Eclipse for their development. And we looked through 40 CVS commits per team. Okay, we did this completely manually, looking through the CVS, the version control system. Right? We couldn't look at the whole history of the system because that would take us manually too long. But we did it manually. We sort of more or less randomly selected different commits, and we manually inspected those. And we went through each change, and we say, yes, that looks like a refactoring. No, that doesn't look like a refactoring. And what was nice about, so there's automated ways of doing this, but the reason for doing it manually is because we can look at each change and use our brains to figure out, did this preserve behavior or didn't it? And what that means is we can find both refactorings that are sort of the standard refactorings that are by the book and we have names for, but we can also find refactorings that we don't have names for yet. We can say, yeah, that's something that preserved behavior, but we don't know what to call it. Okay. So we look through 40 commits per team. All right, so the first question we wanted to ask was, do refactoring tools really support the kinds of refactorings that people want to do? So in the total of 80 commits that we looked at, there was 287 refactorings, and most of those were like standard refactorings you might find in Martin Fowler's book, But 70 of them didn't have tool support in Eclipse. And in some other tools, you'll find some support for these. But Eclipse, which has good tool support, has about at least 20 different refactoring tools. Only 24% of those Eclipse didn't support. And sort of just briefly to talk about the refactorings that the tools don't do, a lot of them were to remove dead code, things like removing unused exceptions, removing unused methods, removing redundant casts. And in fact, even though the refactoring tools don't do this, this is something that the environment supports. There are quick fixes for these. So to a certain extent, there actually are tools for some of these. Significant modifier changing, there was a lot of that, so changing public to private, private to public. There aren't tools in Eclipse for that. There are in other environments, but also things like adding static when it's possible to add static, or removing static even. And these last three swapping statements, these last three are refactorings that we saw a couple of examples of, but I thought were kind of interesting. So one of them is just swapping statements. So suppose you've got two statements that are right next to each other. All right, you change the order of them. That's something you do pretty frequently, right? That's something I do pretty frequently. So, but there isn't tool support for that exactly. Like there's a syntactic change you can make that supports that pretty well, but there isn't actually a refactoring tool that I know of that allows you to swap statements and it will guarantee behavior preservation. Do you guys know of such a tool? Don't think so. Okay, so why is that? So I think this is interesting. Why is there not a tool that will guarantee behavior preservation when you switch the order of statements? It's a pretty common thing, I think. So I think the reason is because if you allowed little changes like that, you'd have a million different refactoring tools, right? And what are you gonna do with a million different refactoring tools? Are you really gonna go to a long refactoring menu to select the refactoring you want if you're just switching statements? Or are you more likely to just do it manually and hope everything works out? So I think that's one reason. So I think that one's curious. Some things you might expect, like using lists instead of arrays. There's not a tool support in Eclipse for that, but I think there are in other environments. And also replacing literals with constants. There's an extract constant refactoring, but if there's already a constant that exists and you've got an identical literal in your program, Eclipse at least can't make that replacement for you. You can only do sort of a greenfield extract constant. So some of the unsupported refactorings, but there weren't many. So the conclusion here is that refactoring tools actually do a pretty good job of supporting the refactorings that people do. So I think if the refactoring tool builders did a really good job on one thing, I think it was this. I think it was picking the right refactorings that people do. Okay, so the second thing is, do refactoring tools work the way that developers refactor? And to answer this question, I'm going to make two different refactoring tactics, and these have two different names. The first type is floss refactoring, and the second type is root canal refactoring. And we've actually already talked about this, and we've heard it actually from both the previous speakers. So Ralph was talking about you need to be making incremental changes. You shouldn't wait until tomorrow what you can do today. It needs to be something you support, something that you're doing all the time. And in fact, that's been the recommended practice for a long time. All the Agile practitioners say, yes, you should refactor a little bit as you go. But it's not entirely clear that everybody does that. I've heard of teams having a refactoring Friday, or I've heard of teams when they get a new code base, they'll spend 2 months refactoring it before they do some development. And so the first type, where you're making your refactorings interspersed with other types of changes, that's what we're calling floss refactoring. Essentially, you're doing floss refactoring to maintain the health of your code. That's where the metaphor comes from. And then the second kind, this root canal refactoring, is this intense and protracted periods of refactoring, where you spend a good amount of time refactoring because the code has kind of gotten out of hand. It's gotten bad, so you need to pay down your technical debt, as they say. And it's not entirely clear. Clearly, that floss refactoring is what's been recommended for a while, but there's not a lot of data about what people really do. Right? Even though your dentist tells you should floss, that doesn't mean everybody does it. And the reason that this matters is because the way the tools work typically aligns with one of the two. So Karen showed us an example of an inline rename where you just say, I want to refactor this, There's not much of a user interface. You just type the thing you want, and basically you don't even see the refactoring tool. And that works really well for this floss refactoring because you need to switch in and out of the tool really fast, and in fact, you don't want the tool in your face at all. Whereas some other tools will give you kind of these heavyweight dialog boxes with multi-step configuration, give you a lot of options, give you the option to preview. These ones that are kind of like more heavyweight, those tend to work better for root canal refactoring. And so which refactoring, if we're thinking about which tool we want to build, we should know which tactic of refactorings developers typically take. So for the study, what we did is, again, we go back to our 40 different commits, but we classify those as either a root canal commit or a floss commit. Okay? And the floss commits are when we mix our semantics changes with our non-semantics changes, our semantic changes with our refactorings. So here's an example where I change cbuff to buffer. Okay, that's a refactoring. It's a rename. But there's also a less than sign that I change to a greater than sign. And so that's a semantics change, right? That changes what the program does. So this is a mix. So we're just going to use buckets here, and we're going to put this in the floss bucket. Whereas we might see some other change where all they did was they changed the name of some method, or they changed the name of 10 methods. That's you might see that too. And if all they did was refactor, we'll say, well, that's a root canal refactoring. All they did was refactor during that commit. Okay. So we did that with all of our changes. I'm only going to present a subset because it'll fit on the slide better. But for one of the data sets, there was 6 root canal refactorings and 11 floss refactorings. Okay, so based on that data, 75% of the commits were floss refactorings. Okay, so floss refactoring, people do a little bit more. But when you dive into the data a little more and you look at each individual change, okay, each of those represents a commit that we compared. If you look at each individual change and you count the number of refactoring in each commit that people did, what you find is that the root canal refactorings are typically a lot smaller. People don't make so many changes in the root canal refactorings. The floss refactorings involved a lot more refactoring going on, but also the changes were a lot more involved. So if you just look at the individual refactorings, 91% of refactorings occurred as part of a floss refactoring. So what I think that means is people are following their dentist's advice. People are taking Ralph's advice, and they are doing floss refactoring, typically. But because most refactoring tools actually are kind of this heavyweight dialogue thing, a lot of refactoring tools don't support the dominant refactoring tactic. That is, they don't support floss refactoring. Okay, and then the last question I wanted to talk about was, do programmers use all of the features of refactoring tools? So we had the full sort of histories of which refactoring tools people used, which configuration options they changed. And so we went through some of the top refactoring tools that people used and looked at each configuration option. So this is the extract local variable, which I called introduce local variable earlier. That has a configuration option where you can make the local variable final. Typically that's false. Typically the designer said, well, typically people don't want to do that. Usually that's false. And then the last column is the toolsmiths is one data set, Mylan is another. The numbers there represent what percentage of the time did they use the non-default value. So in Mylan, 0% of the time did they actually change it from the default, whereas in toolsmiths, about 5% of the time they change it from the default. Okay. And so if you look at some of the other configuration options, the story's usually pretty similar. Typically, the numbers don't exceed about 25% of changing the default values. There's a couple exceptions. There's a 35%. Not sure quite what's going on here, but for the most part, these numbers are quite low. So people actually aren't changing the defaults very much. They're just bringing up the dialog box, saying yeah, whatever. And so, actually, my opinion there, what I think is going on, or what happens with me personally, is that things like take the declare local variable as final. Okay. I could take the effort to move my mouse over, click the declare as final, and then do the refactoring, or I could just do it and type final. It's about the same, right? So when I'm doing it, I don't even bother with a lot of the configuration options. I just, a lot of these things you can just change afterwards, and it more or less works out. Okay, so a lot of configuration options are often left unchanged. So kind of to summarize here, do refactoring tools support the kinds of refactorings people do? Answer for the data that we've looked at appears to be yes. Is the way that refactoring tools work really the way that developers refactoring? Often the answer is no. And then do programmers use the features of refactoring tools? And often the answer is no there as well. So what can we do to make the tools fit better with the way people refactor? So my research is, in addition to the empirical piece, has been developing sort of new user interfaces for refactoring tools. So that's kind of why Roslyn is exciting, because I can sort of reuse some of the infrastructure. My work so far has been in Eclipse because they've had infrastructure for a while. But this could as easily be done using Roslyn. So I want to talk about two of the different tools that we've been working on. The first one is marking menus for refactoring. And so I've got a little demo here, a little video. So this is, the tool's been around for about 3 years now, but we're just presenting an empirical study later on this year. And what we've noticed is one thing that's kind of painful about refactoring tools is the menus. The menus are quite long. Even the context menus, you have to navigate through a lot of stuff. Hotkeys are pretty good, except that hotkeys take a while to remember, and sort of, not necessarily specifically for developers, but in general, it's been shown that people often don't shift to start using hotkeys when they could. It's hard to go from the beginner behavior of using linear menus to the expert behavior of using hotkeys. And so marking menus have been an alternative that have been actually around for a while. We didn't invent marking menus. Marking menus are essentially context menus, except that, I'm terrible at this, except that the items appear in a circle rather than in a linear menu. So if we can get there again. Okay. No. One more. If we can get there again, what we see is there are 4 different refactoring options for this particular menu, and we limit it to 4. And so what's nice about marking menus in general is it allows you to go from basic behavior, which is just point and click, to a more expert behavior, which is gesturing. And why this works especially well for refactorings is that refactorings kind of intuitively have, a lot of the refactorings anyway, have this intuitive structure to them, this intuitive directionality. So typically we all understand the metaphor of superclasses up and subclasses down, and so we can leverage that and map it onto marking menus. And also a lot of refactorings have opposites so that they can go in opposite directions. So what this allows is by sort of combining refactoring with marking menus, it allows you to make refactoring changes a lot faster by sort of gesturing in the direction of kind of where you think the refactoring should appear. This also helps solve the problem with refactoring names, which is I gave you sort of 2 different names for the same refactoring. It's because we can't really agree on any good names for these things. What's cool about this is that once you kind of have a basic idea of where things appear, you can actually guess refactorings that you've never seen. You don't have to know the name. You can just say, well, this makes code, and usually ones that make code go to the right. Okay. So we've got a study about that, which is pretty neat. I can answer any questions about that if you like. Okay. And so, the second tool that I want to talk to you about also came out of the study that I just talked about. And so one of the findings was that a lot of the times the developers we looked at didn't use the refactoring tools that they had with them. And we asked them why. We said, so why don't you use a refactoring tool when you could? And this is one of the answers that we got, which resonated with me and also resonated with some of the other developers, which is, my hands start doing copy and paste without my active control. After a few seconds, I realized that this would have been easier to do with the refactoring tool. But since I already started, well, I'll just finish it and continue. Okay, this definitely resonates with me. This is definitely, I get partway through and I'm like, yeah, there's a tool for this, but I'm almost done. I'll just finish it. So what we want to do is we want to build a refactoring tool that kind of supports kind of a combination of automatic refactoring and manual refactoring at the same time. So we've got a tool that basically you can start a manual refactoring and you can say, you'll get little quick fixes in the gutter and it'll say, finish this refactoring for me. And so what's nice about that is you don't have to realize you're refactoring when you start, which is a typical problem with refactoring tools where you have to say, okay, now I'm ready to refactor. Which item do I want? You can kind of start it manually and you can finish it automatically. So the idea here is to essentially empower programmers to get all the great benefits of refactoring tools without necessarily engaging them on every change that they make. Okay. So just kind of a brief conclusion here. So we've got some emerging data that helps us sort of reflect and think about how people are refactoring in the wild. And when we reflect on that data, we can build better tools. Thanks. Any questions? Paul?
Tools change behavior. The first set of data you presented, your conclusion was that the refactoring tools capture what people do. In your study, did you actually check whether people use tools to do those refactorings? My understanding was that you didn't, but because the other conclusion could be people do what the tools allow them to do and nothing else.
So, okay. So I think there's a bunch of little questions in there. So one of them is the conclusion that I tried to show is that the refactorings that people do in their code are reflected in what the tools allow them to do. Okay. But when you look at did they use those tools for the changes, the answer is actually no for the most part. 90% of the time they made those changes by hand. Okay. Right. So there could be there's a lot of different reasons for that. This last quote I gave you is sort of one. I think there was a second part of your question, though. Is that okay? Okay. Other questions? David?
So the slide you had on toolsmiths and myelin and defaults.
Yeah.
It seems like just because people don't often use change from the defaults doesn't mean that you don't want them there. There are lots of programming features that are rarely used. They might have some benefit. So that's one, just an observation. Yeah. That is, it doesn't mean you want to eliminate those.
It doesn't mean you want to eliminate them, but it may change the way that you build the user interface. So you don't force people to configure your tools, but you make it an option that is sort of emphasized based on how often they use it.
And the second part of that is, are there any of the options that cause different behavior in terms of meaning preservation?
Yeah, I think that there are, and those ones are sort of a mystery to me. So there's one of them where it's like rename class, and it gives you the option of updating references, and you can uncheck that. So you're essentially just changing the name of the class without changing any of the references. I don't know why you would want to do that. But so yes, I think the answer is some of them do change. Some of them do change behavior, but I think most of them preserve it and will actually do additional checks. So if you want your temporary variable to be final, it will make sure that you can actually do that. Chris?
So I have a question just about from the study that you run and just your own experience working with people. If you've seen what characteristics of developers affects how much they use refactorings. So I know, like, if we talk to an undergrad class, they might not know that they even exist. Ex-seasoned developers might say, no, I know they exist, but I want to do it myself. Have you seen differences in, like, maybe age, experience, domain, programming language?
Yeah, so in a lot of the experiments I do, both sort of the case studies and the laboratory experiments, I ask people, how often do you use refactoring tools? How familiar are you with refactoring? How many years of development experience you have? Typically, I don't actually find any correlations between that and their performance on any tasks. I mean, clearly there's an education issue. You know, if you're just coming out of school, there's a high likelihood that maybe you haven't heard of refactoring. Not in my class though. But I mean, I think there's something there, but I haven't really seen it. One thing though that you'll notice is that these two case studies that we did, these actually aren't. This one in particular is not a representative sample. These guys here are actually the people who developed the refactoring tools themselves. And so what was surprising to me when we did the replication for the second people is that the numbers were actually not significantly different. The people who made the refactoring tools versus the people who just used the refactoring tools, their actual usage of the tools wasn't significantly different in a lot of respects. Does that answer your question?
Yeah. I wish the answer was you know, that you did know, and there was some correlation, but yeah, it answers it.
Okay.
Okay, I think with that we'll end this. Oops, we have one more question.
Yeah, I'll just say, when you're talking about floss versus root canal, and how well current tools support it, I think we're referring to Eclipse, that the people who were developing it thought they were building something that was well suited. They were actually aiming for floss refactoring. And the real issue, which maybe you didn't make clear because it's too obvious to you, is the importance of good user interface design. And software engineering people, and researchers in particular, have a tendency to user interface design is what the people over down the hall study. That's not what we study. And so they have a tendency to build sort of clunky user interfaces. I mean, you sort of see that lots of places and it's really important to have good user interface design. We're building tools for users. Our users happen to be programmers, but still, you have to have really good user interface design. And so, yeah, I think that there's a sense in which it's really the user interface being a bit clunky that leads you to think that.
I agree.
Okay, great. Well, thank you very much for coming, and I'd like to thank all the speakers.